Recorded is rolling. It is Wednesday, March 18. Today and tomorrow will be Alex days. A lot of you guys didn't have to make a 10-1, 10-2 from last week, so that's open for you guys. Of course, this week we've been covering 10-3, 10-4. Also, don't forget too, you can work towards your 90% high goals. A few guys are a little shy even of the 70% high goal. Right? You may have been like 95% of the way there or something, right? So you can always work on your high goal too. And then Friday, I'll have an activity for you guys that also involves probability that will take us to spring break. Oh, I did return all your papers. So anything that you turned in, including old quizzes, if you want to do quiz corrections, that's something you can work on too. Quiz corrections if you do something like that. Okay. Here, I do want to do at least one with you guys. So here I have the 10-3, 10-4 assignment pulled up. Um, this one was a bit challenging. Now, every time I refresh this, it changes the question, but you guys had basically the similar type premises or the math would be the same. So I'm pretty sure I can get this right. I'll walk through this with you guys. This is number 10 on your most recent assignment. Here it is, 10-3, 10-4. And so we got this auto superstores thinking about offering a 2-year limited warranty for $934 on all new cars of a certain model. The terms of the warranty would be that this company would replace the car free of charge under certain specified conditions. Right. So suppose you get a car and it's completely a lemon, it's just breaking down, and like, oh, this car is like terrible, right? Which happens sometimes. That's why they have a term for it. They call it a lemon, right? Replacing the car this way would cost $12,100. Suppose that under the warranty, there is an 8% chance that the warranty would be um, would be enacted, so that you have to replace the car one time. Okay. And a 92% chance that they would not have to replace the car. Okay, so these cars break down 8% of the time. Okay. Now, guys, break down those numbers, and I'll write them down off screen here. All right, let's get those numbers on the board here. We got warranty cost equals $934. Okay, which is optional. So you as the customer going to buy this car. Do you want the warranty? It would cost $934. Like, well, there's an 8% chance the car will break down. Up to you. And then the warranty payout would be is $12,100. Get that? Okay. And the car breaks. Hence, you need to pay the warranty 8% of the time, and the car is good the other 92% of the time. Okay. Again, on your own particular Aleks, there are different variations on this question, so you may get a slightly different version. Okay. So down to the question here, though. They know they will sell many of these warranties, let's say hundreds or thousands or millions, whatever. Okay. Should expect to make or lose money, and by how much? To answer, take into account the price of the warranty and the expected value of the cost. Expected value right here from replacing the car. Now, before I go chugging through the math, I want you guys to think big picture. So let's see the forest for the trees, and maybe play around with the variables in our minds. This is something I tell my physics students all the time. Think about is uh, it is expensive to replace the car, but we are making a little bit of money maybe on every car. And most of these warranties we don't have to they don't have to be enacted because the car's fine anyway. Okay? But guys, what about this? What if this 8% chance of the car breaking down? What if it was like 50%? So like half the time you have to pay it. Okay? Well, then would this company definitely be making or losing money? Yeah, losing for sure. And that's maybe more obvious to see. Because if half the time you have to pay $12,000 and you're only making 900 something dollars every warranty you sell, right? That's definitely a losing proposition for the company, right? On the other hand, what if you go the other way of the percentage? What if none of the cars break at all, right? They're all completely good. Then isn't the company basically getting $934 for free every time it sells a warranty, which is never even going to be used, right? Okay, so what we have to do is we have to bring in probabilities, percentages to say, well, what's the expected, here's the key phrase right here, expected value, right? Like over the long run, if we sell like hundreds or thousands of these warranties, right, what's the expected value? Because if it's a positive, then the company would want to sell the warranties, like according to this plan, that would be all good. But if it's negative, then well, there's something wrong, and maybe you have to go increase the price of the warranty or make better cars or both, right? So I'll say expected value equals, right? And I'm pretty sure I'll set this up right, but we'll see. We'll come up with the equation, we'll get an answer, we'll plug it into Alex, and we'll see if it likes our answer. Okay. Now, I think that, well, every time they sell a warranty, they would be doing that 100% of the time they sell it. So I'm going to say positive $934 every time they sell a warranty, which would be 100% of the time they sell a warranty. Guys, what's 100% as a decimal?
1.
Yeah, 1.00. Okay. So every time they sell a warranty, they sold a warranty, right, by definition, right? Okay. Then plus, right? Then sometimes they need to pay out this 12,000 something dollars. Okay, so how often do they have to do that? What percent of the time do they have to pay out?
First, 0.008.
Yeah, 8% of the time. So I'm gonna say negative, and I go $12,100, and let's yeah, say 0.08. I like that as a decimal because that's what 8% is. It goes right there, right? Okay. Now I'm pretty sure you don't have to directly use this 92% numbers. It doesn't actually show up in the math, right? Um, but I do need these other numbers. Is that okay if I set up that equation that way? I'm just thinking this through logically. I'm pretty sure this should be the answer. Okay. All right, so let's see if they're going to gain or lose money because here's a positive value, here's a negative value. So what's the net effect? So $934 for every single warranty they sell. And then minus $12,100 payment for the 8% of the time, or 0.08, that's decimal, right? That the car breaks, which will happen sometimes. Okay. Okay, so, ooh, I'm getting a negative value. It's negative $34. It means every time they sell one of these warranties with this set of conditions, these numbers, okay, they should, in the long run, expect to lose $34 per warranty they sell. Okay. So, guys, is that a good deal for the company?
No.
No, although if you're a customer, it's actually pretty good, all right? Okay. So this company needs to do one of two things. They need to either go increase the price of the warranty, I guess up to, what would that be, $968 to at least break even? Yeah. Or just build better cars, right, that aren't breaking down so often, or both. Right? So let's see if that's what they like here. I know I saw this with someone yesterday, and we were getting this right. So can they expect to make money, lose money, or neither make nor lose? Because which of these would you check based on the math you just saw?
Lose money.
Yeah, they're going to lose money, and I'm pretty sure it should be $34 per warranty sold.
Wait, Mr. Griffin.
Yeah.
If I do the equation and it's a positive number, that means they gain money, right?
Yeah. If it's positive, then they're gaining money from the warranties. Right. And then, okay, oh, here, I'll check this answer. Yeah. That's exactly what they were looking for. Okay, right. Yeah, so that one's a little more nuanced thing, so I wanted to do at least one with you guys. Okay. All right. All right, so if you need me for anything, or if you're stuck or have any questions, then call me over and I'm happy to help you out.